Hi, Sue. Thanks for coming. As a representative of one of the RTOs that we are working with in Nanopad, and as you are using the three different Nanopad technologies, the PDW, OF2i and TUS, I would like to get some more of your experience that you shared with us. So first of all, what are you producing at nanoscale, at scale, in your labs at the University of Basque Country and POLYMAT?
First, thank you, Beatrice, for inviting me to this interview. So in POLYMAT, as the name says, polymeric materials, we work with polymers, with plastics, and with synthesize something that is called latex, which are polymeric nanoparticles dispersed in water. And these are, for example, used to then synthesize paints, coatings, etc. Because at the end, in all the application of paint and coatings, we have a liquid. So we put the liquid, for example, the paint in the wall, and then this is dried, filming a continuous film. So this film, the basic that forms this film, is the binder of the polymer nanoparticles.
And now that you have begun using these different three parts, which advantages or benefits could you highlight by using them in your processes?
Yeah, the first thing that I will highlight is that with the three of them, we are able to get information real time, because till now, at the end, every time we wanted to know which was the particle size that we had in the reactor, we had to wait on a sample, go to an external technology, measure it, prepare the sample, measure it. So at the end, it was quite time consuming, and we were not able to get real-time data. We always had a quite big time shift between the time that we were getting the sample and the time that we were getting the results of the particle size. Now we are able to have this information in 2-3 minutes. Apart from that, I will say that each of the techniques also have some different things. For example, the PDW is an inline monitoring technique, so we have a probe that is directly immersed in the reactor, and we are able to measure the particle size of the latex directly from its system without modifying anything. So that's a really good thing, even when we are working with high solid content and high particle sizes, because at the end it's observing how it emits a light, and it looks how this light is decreasing the intensity, and the phase are decreasing after collisioning with a lot of particles. So this is a really good thing. Regarding the other two, they are online monitoring techniques. So in both of the cases, we have a dilution system, but which may give some problems that I will talk about it after. But for example, a really good thing is that in the OF2i, even if we have to dilute the sample, we only need to take some microliters of sample from the reactors. That's a very, very little amount, and it's a little amount for a lab scale where we are working 1-2 liter reactors, but even less significant in an industrial scale where we are creating hundreds of tons of material. So this is already a really good thing. And related to the TUS, it's also an online technique. And I will say that one of the most important things of this technology is that we were able to know which the appropriate dilution was on an automatic way. So with the turbidity spectroscopy, we are measuring the transmission of the sample, and then using the wavelength exponent method, we retrieve the particle size, and observing the characteristic of this transmission curve, we are able to say if the sample was diluted enough or not. And it's something that still is very challenging in a lot of online measurement techniques. Most of them, you need to know the dilution beforehand. But in the emulsion polymerization processes, the ones that we are working with, this is very challenging because the particle size and the solid contents are changing together. So having this automatic selection, it's a really positive thing.
It sounds very promising.
Yeah.
Have you been able to win knowledge in any specific scientific field using these parts?
Yeah, in this case, we have been working mainly in emulsion polymerization for polyacrylate polymer synthesis. So we're able to see not only the particle size increase during during the production, but also some phenomena that can occur, because sometimes we are producing it and in principle we have a theoretical, very beautiful particle size constant increase, but we may have some problems, like for example aggregation, coagulation, creation of new particles, etc. And we have been also testing these technologies to detect this kind of phenomena. And even if the detection of the new nucleations was really challenging, and we still have to go a bit more into detail to see if we are not able to see something on it, we have to say that we are, for example, with the PDW, we can completely observe the aggregations. So this is really important, so that then we are able to create some control systems and detect if everything is going as expected or we are having these phenomena.
Mm-hmm. And one last question. Could you share with us which challenges or issues have you experienced with the use of these three technologies?
Of course. First, I would like to emphasize that the three of them are really good technologies, because at the end, being able to measure this in real time is very challenging. So starting from that, I would like to leave this very clear. And going a bit now into the challenges that you have asked, I will say that there is a challenge that is still remaining in the three of the techniques, that is the problems to be able to measure the particle size for very small particles. So with the three of them, we were able to at least see the particles or detect that we were having something in the dispersion for particle sizes bigger than 100 nanometers, but going to lower particle sizes, at least with the polyacrylates polymers, it's really challenging. This is also something very system dependent. It depends on the refractive index of the material, but for the polyacrylate case, it was very challenging. And on the other hand, the problem that I was a bit explaining before, that for the online technologies, for the OF2i and TUS, we need to use a dilution system, and depending on the kind of material, this could be quite a big issue, because we may have some aggregation inside the system, etc., because we are not observing directly the material itself. But I think that there are things that at the end we are working with techniques that they are under development, that they are giving us very good impression and results for this first analysis and test, and we are looking forward to continue working with them and see also how we can overcome these little issues that we are observing with the dilution or with the small particle sizes.